Let's go to liquid 3638, maximal balanced shipment. So it gives us integer weight. And a shipment is defined a continuous story of um, uh, parcels. And if it is considered balanced, if the weight of the last parcel is strictly less than maximum weight among all parcels in the shipment. So we want to find the maximal uh, possible number of balanced shipments and say that each parcel appears in at most one shipment, and also this kind of shipments should be non-overlapping. They should um, get all of the weights. So that is just a array partitioning problem, right? So I say this one has need two, right? It is asking us what's the maximum partitioning for this array, and we need the last element should be in this element should be strictly less, or was it not equals the max of the this subarray, right? So what we're thinking about is that we have group iterations. So we'll see. We want to have the subarray in this kind of format, right? So if there is any increasing, that means we can uh, use this one to be merged into the next decreasing array, right? And also for this decreasing array, if we see the decreasing array, what is the size? If it has two, right, means we need a one shipment. So at least decreasing. So what we want if we see those kind of decreasing parts, if we divide by two, right? So that's what add our result. So the total shipment, well, we check in the decreasing um, uh, subarray, which divide by two. That's our result. So let's write code for this. So we are going to have int n equals weight dot length, and we can have a count, right? So that if it is a consecutive decreasing, we just set that as count. If it's um, not decreasing, we reset as zero, right? So result equals to zero. So what we do is for int I equals to zero, I smaller than I plus plus. So we're going to have count should increase, right? Every time we. So if we have I equals n minus one, or array I plus one is greater equal to array I, right? Means this is not a strict decreasing, right? We should set this count equals to zero. And before we set this to zero, we need our result should add equal to count divided by two, right? So that will be our result. So return result. It will be O(n) time complexity with constant space complexity. And the Python code is very similar. So we have n count result equals the length of weight in the count to be zero and the result to be zero for I in range n, right? So we have should account should increase by one every time. So if I equals n minus one, or array I plus one is greater equals to array I, then this is not the end of the continuous decreasing, right? So we have a result should plus equal to count divided by two. And also we need to reset this one as zero. And in the end, it's a return result.